All right, so what I'm going to look at here is solving equations where your unknown is in the index or in the power. Okay, so something like this. 4 to the power of x is equal to 16, and I'm asked to solve for x. Okay, so we've solved equations before where we get something like 7x is equal to 21, and we divide both sides by 7. 3x plus 2 is equal to 29. We might bring the 2 over and then bring the 3 over and solve it. We've even solved them where it's like x squared plus 7x plus 12, and we just factorize it or use the minus b or something like that. For equations like this, where the unknown is up here in the power, there is a different technique that we need to learn. What I would say with this one first is 4 to the power of x is equal to 16. So 4 to the power of something is equal to 16. Well, 4 squared is equal to 16. Okay, just know that. So x here must be equal to 2. All right. What I'm going to do though is just go down through the steps to solve this, because we'll need to use those steps for later trickier examples. Okay, so 4 to the power of x is equal to 16. The first step in solving these is to write both sides with the same base. Okay, so write both sides as 4 to the power of something. So the left-hand side is already written as 4 to the power of something. It's 4 to the power of x. What's 16 as 4 to the power of something? It's 4 to the power of 2. So now I've got 4 to the power of x equals 4 to the power of 2. Well, that means x must be equal to 2. Okay, so if you have both sides to the same base, so both sides are 4 to the power of something, you can just put the powers equal to each other. So x is equal to 2, and that's it, solved. Okay, like I said, I was able to kind of see that one, but that's the steps you'd go through. So the next example here, I've got 3 to the power of x is equal to 81. So let's try and write 81 as 3 to the power of something. Well, I know that 3 squared is 9. 3 to the power of 3 is 27. 3 to the power of 4 is 81. Okay, so writing both sides as 3 to the power of something. Left hand side, 3 to the power of x. Right hand side is 3 to the power of 4. So that must mean x is equal to 4. And you can check your answer there by subbing. So well, we've already done it, but 3 to the power of 4 is equal to 81. So if I was to sub 4 back into my question, I would get 81. Okay, it works. Next one here, 16 to the power of x is equal to 64. So let's try and write 64 as 16 to the power of something. Now 16 squared is equal to 256. Okay, so I've run into a problem here. All right, my left-hand side is 16 to the power of something. My right-hand side, I can't write it as 16 to the power of something, because as soon as I go to 16 squared, it's 256 and it's too big. So I need to write both of them as a kind of smaller number to some power. So just looking at both of them, 16, you can write that as 4 squared. So 4 squared is 16. And then what's 4 to the power of 3? It's 64. So I can write both sides here as 4 to the power of something. And that's what I have to do. So 16, I'm going to write that as 4 to the power of 2. And that is to the power of x is equal to 64 is 4 to the power of 3. Now I want to write this left-hand side as like a single 4 to the power of something, not 4 to the power of 2 to the power of something else. So what I'm going to do here is just use this rule of indices that we were looking at before. So when you've got 4 squared to the power of x, you can multiply those two powers by each other. So that left-hand side is the same thing as 4 to the power of 2x. So you multiply the powers by each other, is equal to 4 to the power of 3. So now both sides are 4 to the power of something. So I can put the powers equal to each other. So 2x is equal to 3, and just a little bit more to solving this one than the earlier ones. I'm solving for x here, so I'm going to divide both sides by 2, and I get x is equal to 3 over 2. And that's me done. Okay, so once you kind of put the powers equal to each other, it's the normal rules of solving a linear equation, of moving stuff over or doing the same thing to both sides. Okay. Could I have done that question a different way? I wrote both sides as 4 to the power of something. Could I write both sides as 2 to the power of something? What's 2 to the power of 4? 2 to the power of 4 is 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. So I actually could have written both of those as 2 to the power of something as well. And I will do that now, just to show you there was a different method available to me here. So write 16 as 2 to the power of 4. So 2 to the power of 4 to the power of x is equal to 64 was 2 to the power of 6. So using that same rule here, 4 multiplied by x. So 2 to the power of 4x is equal to 2 to the power of 6. Both sides are 2 to the power of something, so put the powers equal to each other. So 4x is equal to 6. So x is equal to 6 divided by 4, and 6 divided by 4 is 3 over 2. So I got the same answers doing it both ways. Okay, so it wouldn't matter. You can use this method here of writing both sides as 4 to the power of something, or this method over here of writing both sides as 2 to the power of something. You get the same answer in the end. Okay, if you want to check your answer here, same way we always do. So just sub your answer back into your equation. So 16 to the power of x, so 16 to the power of 3 over 2. And that's equal to 64. Okay, so my equation holds. All right. That one I wouldn't have been able to do kind of just by inspect. Like here, I could have got x is equal to 2. Here, I could have got x is equal to 4 without going through these steps. But for this example here, I really needed to go through those steps to get my answer. Okay. What I would say is most of these questions, I would say you're going to be looking for 2 to the power of something, 3 to the power of something, 4 to the power of something, 5 to the power of something, maybe 10 to the power of something will come up sometimes. But I would say that's kind of what you're looking for each time. That will be the common base. Okay, like they could ask you kind of an infinite number of kind of ways, and there could be all sorts of numbers we could be writing both sides as something to the power of. But I think they will keep them limited to 3 to the power of something, 4 to the power of something, 2 to the power of something, maybe 5, maybe 10, but I don't think any other numbers would come up. So they're the numbers you should be looking to write both sides to the power of. They might even give you a little prompt or a little hint as they want you to write both sides too, and I'll show you that in a later example. So just next one I've got here. So fourth example, so 2 to the power of x minus 1 is equal to 8. So my unknown is up in the power, so I need to write both sides as 8 here, I think is 2 to the power of 3. 2 to the power of 3 is 8. So I can write both sides here as 2 to the power of something, so that's what I'll do. 2 to the x minus 1 is equal to 2 to the power of 3. So you've got 2 to the power of something on both sides. So that means you can put x minus 1 equal to 3. And then bring your minus 1 over, it becomes plus 1, x is equal to 3 plus 1, so x is equal to 4. Okay, and looking at it, 2 to the power of 4 minus 1, 4 minus 1 is 3, so 2 to the power of 3 is equal to 8. So 4 was the answer there. That's just showing you that it is the kind of normal rules of a linear once you put the two powers equal to each other. Fifth example here then, so 4 to the power of something equals 32 to the power of something. So let me see, let's try and write 32 as 4 to the power of something. 4 squared is 16. 4 to the power of 3 is 64. So I'm going to bust, it's too big. So I can't write 32 as 4 to the power of something. So I could write 4 as 2 squared. Can I write 32 as 2 to the power of something? Well, it's just in my head from earlier. 2 to the power of 5 is 32. So the key here is to write both sides as 2 to the power of something. Okay, so if it doesn't work that you can't write 32 as 4 to the power of something, look for something else. Okay, so 2 in this case. So I'm going to write 4 as 2 squared, and it will still be to the power of x minus 1 is equal to 32 is 2 to the power of 5. Now, remember from an earlier example, I want both sides as just 2 to the power of something. I don't want to have double powers like this. So I'm going to use this rule of indices here that says if I've got 2 to the power of 2 to the power of something else, I can multiply these powers by each other. Okay, just be careful when you're doing this. So it's going to be this power multiplied by all of this power. So 2 by x is 2x. 2 by minus 1 is minus 2. And that's equal to 2 to the power of 5. Now I've got both sides as 2 to the power of something. I can write the powers equal to each other. So 2x minus 2 is equal to 5. So now bring the minus 2 over. 2x is equal to 5 plus 2. 2x is equal to 7. So bring the multiplied by 2 over. It becomes divided by. So x is equal to 7 over 2. Does that work up here? 4 to the power of, and I'll just use brackets here because it's going to get a bit complicated, 7 over 2 minus 1. So 4 to the power of x minus 1, 4 to the power of 7 over 2 minus 1, it should be equal to 32. And it is. Okay, so that's me checking my answer. All right. Again, because you're writing both sides there as 2 to the power of something, they might give you a little prompt in the question. So like a part 1 of that might be, write this in the form 2 to the power of something. Write this as 2 to the power of something. Okay, they might give you a prompt there where you do have to kind of find another common base. So example 7 here that I'll go on to in a second kind of shows you where that's being done, where they kind of give you a clue. Part 6, solve for x. 3 to the power of x is equal to 1 over 27. Okay. So 3 to the power of x is equal to, well, let's write 27 as 3 to the power of something first, and then we'll deal with the fact that it's a fraction. So 3 to the power of 3, I think, is equal to 27. So 3 to the power of x is equal to 1 over 3 to the power of 3. So I'm rewriting 27 as 3 to the power of something. Now, I want to get rid of the fact that I've got a fraction on this side, and remember that 1 over is the same thing as a negative power. And we need to be able to kind of go both ways with this rule. Start with it looking like this, and go to the fraction, start with it as a fraction and go that way. So 1 over 3 to the power of 3 is the same thing as 3 to the power of minus 3. So 1 over is the same thing as a negative power. So 3 to the power of x is equal to minus 3. So I've got both sides as 3 to the power of something. So I can just put the powers equal to each other, and it is x equals minus 3. All right, let's just try it here. 3 to the power of negative 3 is equal to 1 over 27. That's me checking my answer, and it works. All right, last example then that I will do, and this is the one where I'm kind of showing you where they might kind of give you a little hint in a question. So it tells me write 25 to the power of x and 1 over 125 in the form 5 to the power of k. So write both of these as 5 to the power of something. Hence, solve this equation. 25 to the power of x is equal to 1 over 125. Because if I just started with 25 to the power of x equals 1 over 125, I might try and go write 125 as 25 to the power of something. But if I do 25 squared, it's 625. It's already bigger than 125. So I'd obviously need to find some other base that's common to both sides. Here, they're telling you that that base, which is common to both sides, is 5. So this is what I mean about them maybe giving you a little hint like this, or maybe breaking the question up. All right. So write 25 as 5 to the power of something. So 25 to the power of x is equal to 25 is 5 squared. So 5 to the power of 2 to the power of x. So just rewriting the 25 as 5 squared. And then power inside and outside the bracket like that. I can multiply the powers. So it's the same thing as 5 to the power of 2x. So 25 to the power of x is the same thing as 5 to the power of 2x. Let's do the same thing then with 1 over 125. So first thing I will do is write the 125 as 5 to the power of something. Let me see now. 5 cubed is 125. So it's 1 over 5 to the power of 3. They don't want it as 1 over 5 to the power of something. They just want 5 to the power of something. So I need to get rid of this 1 over. And again, remember, 1 over is the same thing as a negative power. So this is the same thing as 5 to the power of minus 3. All right. So now they ask me to solve 25 to the power of x is equal to 1 over 125. Well, I've rewritten 25 to the power of x as 5 to the power of 2x. I've rewritten 1 over 125 as 5 to the power of minus 3. So I have both sides as 5 to the power of something. So I can put those powers equal to each other. So 2x is equal to minus 3. So x is equal, to bring the 2 over, it becomes divided by minus 3 over 2. All right. So is 25 to the power of x, is 25 to the power of minus 3 over 2 equal to 1 over 125? Let's just plug it into the calculator. 25 to the power minus 3 over 2 is 1 over 125. Okay, so my solution was correct. All right. So look, as I said, if it's one of the trickier ones where you don't just write both sides to the power of like, say here it was easier because I had 3 to the power of x and I was able to write both sides as 3 to the power of something. Here would have been a bit trickier because I couldn't write that as 25 to the power of something. I had to find a common base on both sides, and it was 5. That's where they're kind of giving you the hint that it's going to be 5 to the power of something. We've seen earlier questions where I needed to figure that out myself. If it is one where you need to figure it out yourself, what I would say is I'd be looking for 2 to the power of something, 3 to the power of something, 4 to the power of something, 5 to the power of something, maybe 10 to the power of something, just because that tends to work out nicely. But I don't think they'd be looking for you to find any other common bases. So they're the ones to look out for if, as I said, it's not so straightforward like this.